Hello friends, I'm Bob. In this video I will be showing you the solution to the integration of 1 over 1 minus x squared dx in 4 different ways. But before I do so, if you guys like the solution and the video, press the thumbs up icon below this video. The first way that we can do is to first split the denominator up into the following, which is 1 minus x, 1 plus x. Then we will apply the technique, which is the partial fraction decomposition. My 1 over 1 minus x, 1 plus x is equals to a over 1 minus x plus b over 1 plus x, in which a and b are constant to be determined. Then we multiply both sides of the equation by 1 minus x, 1 plus x. We get 1 is equals to a 1 plus x plus b 1 minus x. The next step what we can do is we are going to find what is my constant a and constant b by substituting first x is equals to -1. So when x is equals to -1, we'll get 1 is equals to 2b, and hence we will be able to get my b, which is half. To find what is my a, I just substitute x is equals to 1, and I will get 1 is equals to 2a, and hence a is equals to half. I found my constant a and b. I substitute into the partial fraction equation. I will get the following, which is 1 over 1 minus x, 1 plus x. This is equals to half square 1 over 1 minus x plus 1 over 1 plus x. So for this particular steps, we first substitute a and b into the equation. Then after that, we factorize the half out of the equation. Now we have split this up into two different fractions using partial fraction decomposition. I can now substitute back into the integral here, in which I will get the integral of half square bracket 1 over 1 minus x plus 1 over 1 plus x close bracket dx. I factorize the half out of the integral. I get half the integral of the following. Then the next step, I will split the integral out into two different integrals, and we get, in which now we can evaluate the integral. So for the first integral, the integral of 1 over 1 minus x is basically just the negative of ln 1 minus x. Whereas for the second integral, the integral of 1 over 1 plus x is basically just ln 1 plus x plus c. And we now combine the two lns to make it into a fraction, and we get the following, which is 1 plus x over 1 minus x plus c. So the final answer to the integral of 1 over 1 minus x squared for this first way is half bracket ln bracket 1 plus x over 1 minus x plus c. The second way of solving this problem is very similar to the first way, just that we do not use the partial fraction decomposition method. For the first step, we are going to split the denominator up into 1 minus x, 1 plus x. And then the next step, outside the integral, we will multiply by half, and within the integral, I will multiply by 2. Following which, in the numerator, I will add x and subtract x. This fraction can be further simplified into the following, which is 1 plus x plus 1 minus x, and in this form. So from here, I can now split the fraction up into two fractions or two integral in the following manner. So for the first integral, I will have the integral of 1 plus x over 1 plus x 1 minus x dx. And for the second integral, the integral of 1 minus x over 1 plus x 1 minus x dx. For both of the integrals, I can now do the cancellation in this manner, and hence I can simplify the question into the following. I can now evaluate the integral. So for the first integral, the integral of 1 over 1 minus x is basically just negative of ln 1 minus x. Whereas for the second integral, the integral of 1 over 1 plus x is just ln 1 plus x plus c. And last but not least, I put it all into a fraction and it should look something like this. So the final answer to the integration of 1 over 1 minus x squared dx is half square bracket ln bracket 1 plus x over 1 minus x plus c. The next way in which you can solve this problem is by applying the technique called integration by substitution, in this case trigonometry substitution. We let x be equals to sine u and we differentiate x with respect to u. This gives me cosine u, in which multiplying both sides by du I get dx is equals to cosine u du. So now I can substitute my x as sine u and my dx as cosine u du. This is also the same as the integral of 1 over cosine square u cosine u du. So from here to here, I'm applying the trigonometry identity that 1 minus sine square u is equals to cosine square u. This is the Pythagorean theory of the trigonometry identity. So my numerator is cosine u, my denominator is cosine square u. I can just basically cancel, simplify, and we get the following 1 over cosine u du. This is the same as just integrating secant u du. So the integral of secant u du would be just basically equals to the ln of secant u plus tangent u plus c. To find out how to evaluate integration of secant u du, I'll put out a link in the video on the top right hand corner, directing you to the video showing the integral of secant u du. And the secant u can be rewritten as 1 over cosine u. My tangent u can be rewritten as sine u over cosine u plus c. And then I can combine the two fractions together. I will get 1 plus sine u over cosine u plus c. And now we need to substitute back to express the integral in terms of x. But how do we go about doing it? We focus on this trigonometry substitution, which is x is equals to sine u, and we know that we treat u as an angle. My x itself is the opposite length of the angle, which is x, and then my hypotenuse basically is just 1. So my sine u is equals to the opposite over hypotenuse. And to find what is my adjacent length to the angle itself, I will do the Pythagorean method, and I will basically just get 1 minus x squared, the square root. That will be the length of the adjacent for the angle u. So using this particular information, I can now express the answer in terms of x. I know that my sine u is x. How about my cosine u? My cosine u is basically just in terms of the right angle here, the adjacent over the hypotenuse. So adjacent is square root of 1 minus x squared, and hypotenuse length is 1. So basically I have the final answer, which is as follows: the ln of 1 plus x over square root of 1 minus x squared plus c. And the fourth way of performing this integration is by using the technique called the hyperbolic substitution. So applying the integration by substitution techniques, this time around we will substitute my x as the hyperbolic tangent of u. And then to find out my differentiation, I differentiate x with respect to u, I will get the hyperbolic secant square of u. And using this particular information, my dx is equals to the hyperbolic secant square of u. I substitute them into the integral. I'll get to the following, which is the integral of 1 over 1 minus hyperbolic tangent square of u, and my dx basically is hyperbolic secant square of u. We will apply the trigonometry identity that 1 minus the hyperbolic tangent square of u is equals to the hyperbolic secant square of u. So we get the following: 1 over the hyperbolic secant square of u times the hyperbolic secant square of u du. And we can further simplify into just the integral of 1 du. So the integral of 1 du is basically just u plus c. Last but not least, we substitute my u as the hyperbolic inverse tangent, and the final answer is basically just the hyperbolic inverse tangent plus c. In this video, I have shown you 4 different ways in which we can solve the integral of 1 over 1 minus x squared dx. If you guys like the solution, help me press the thumbs up icon and do consider to subscribe for more interesting integration problems. I'm Bob. Thank you guys for your support, and I will see you in the next video. Goodbye, guys.